on one side, right? So what was our inputs? So X, Y, Z output is F. So we're going to have X, we're going to have Y, we're going to have Z, right? Then from there, I want you guys to basically just draw a straight line. Excellent, yeah, the straight line. Here's the straight line. And then from there, we're going to do the first gate. So now, for the first gate, we have X, Y naught, and Z, right? And then X, Y naught, and Z, which gate do they go into? Which gate must we use for X, Y naught, and Z? An OR gate, yes.
It's an OR gate.
So this, yes. So this is basically a 3-input OR gate, 3-input OR gate. So it's basically X, Y, Z, right? Now, if you come here, you see that this is Y naught, right? Remember I said you can get away with just using 3 gates. The OR, the AND, and the inverter, right? So now here we are already inverting the Y. So now here we will have Y. I said here, when you join these things, please just do like something like a full stop so that we can see that you joining them here, X, Y, Z. So this will be X, Y naught here. After the inverter, it will be a Y naught, and then Z. Then it will go into a 3-input OR gate, as you said. 3-input OR gate. All right. So the next one is X, Y naught, Z naught. Again, 3-input OR gate. We're only going to invert Y and Z. So we're going to invert Y and Z. Y, Z. Okay, let me somewhere bring this one here. So this one we inverted with an inverter here. And here as well, we're going to put the inverter. And then this one here. So here, our inputs into this OR gate that we're gonna draw now will be X, Y naught, and Z naught. So they will go into a 3-input OR gate. So now, how many is left? Okay, I'm gonna do this one as the last one. So this is, let's do the easy one. Let's do this one as the last one. This is X naught plus Y plus Z. X naught, let's somewhere put the inverter here because we know it's a not X. X naught, Y, and Z. Still into a 3-input OR gate. I know I left one gate, guys. I'm just saving time now. But yeah, you will basically just do the same thing that you did here for that gate. Sorry, I wanted to come here. All right. So now, all of these gates here, these 4 AND gates, these 4 OR gates, they need to be ANDed together. Check. So you need to AND this gate, and this gate, and this gate, and this gate. So you need to end it by having a 4 input AND gate. 4 input AND gate. So that 4 input AND gate will have this combination, and this combination, and this combination, and this combination. So basically it will consist of 4 OR gates. 4 OR gates which have like 4 3 inputs OR gates. Where is it? All right. So now this is our AND gate. Okay, let's just run this one. Let's pretend this is that one that we were lazy to do. So now our output will be F. So F will consist of X, Y naught, Z, right? Here X, Y naught, Z naught, X naught, Y, Z naught. Everything will be fed into this AND gate, and then our expression will be the same as it is here in this question paper. So that is basically the answer for this. So this, guys, you can do it in less than 5 minutes. You mustn't take the time that I took. I took that time because I can't draw quickly. So please do this very, very quickly. Don't even waste your time, because you're gonna struggle when you get here. When you get to things like sigma notation, things like Carnot maps, most students, they don't finish basically the exam paper because they like spending too much time on these drawings and stuff. So yeah, so if you can, I'm not saying rush, but make sure that you save as much time as you can. Okay, so this is basically the logic circuit, and then in short, the logic circuit, remember what I said? You need to know your OR gate, you need to know your AND gate, you need to know the inverter. And then put all your inputs on one side. These are the inputs. Just draw a line where you join them, put a full stop so that we can see. Yeah, and then basically that's it. And then F, most of the time, actually all the time, F is always your output. Yeah, so F, you will put it this side. If you have time, how I do it is when I get here, I always write the output so that I don't make a mistake. So this is basically X plus Y naught plus Z. I always do this so that I know that I didn't make any mistake. So this will be X, Y naught, and Z. Even here, I was gonna write the same expression. The expression for this gate, the output here, and here the output here. And then even here, you can do that or just write F. Do you understand? Then that will definitely give you more than full marks. So full marks, which is equivalent to full marks anyway. All right, let's go to the next one. Okay, are there any questions there?
No.
All right. Let's go to the next one. Okay, convert this one to POS. The domain is ABC. Okay, that one is very hard. Let's see. Sigma notation. Okay, let's do the sigma notation one. Okay, guys, please tell me, how did you do this one? The sigma notation. How would you do this one?
I'm not sure if I'm correct, but I used that method that you showed us with the it's like you write out, okay, what the binary form is, and then you check 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and then you check where is it in that, I don't know how to explain it, in that line, yes. That's the method.
Understood. All right. Now for this one, how much did you get for the first one, or for any?
For the first one, I got 15, and that actually confused me because I thought, because at some point I also got a 32.
All right. Thank you. Okay, great stuff. Next, is there anyone with another solution? All right. In 3, 2, 1. Okay, there's no other solution. All right, guys. This E was actually a typo. Now imagine how painful was this. Students wrote the exam. They struggled for more than 30 minutes. Even me, the first time I saw such a problem, I did it the way the lady was saying. I did it the same way, only to find out that this E was a mistake. It was a typo. So in short, you need to look at how many variables are there in your expression, basically. So you only had A, B, C, D. So you were supposed to scratch out the E. You understand? I think it killed students for 2 times already. Which year was this? 2015. Okay, I'm not sure about 2015. I don't think I was there. Oh no, I think I was there. Yeah, so I'm not lying to you guys because I was there 2015. Let's see. Yeah. So this E.
Sorry to disturb you. In the exam now, say we get a question that has the same setup. Is figuring out that the E is part of it, a part of the whole solution, or it's an error, then we'll get the 7 marks.
Yeah, it is an error. You will get the 7 marks.
Okay.
But my point is, that is not the problem. The problem is if something is like this, and then you want to solve it and check. This is question 3. This paper had, okay, yeah, it was up until question 3.5. Students, they spend a lot of time here. Some took, for example, more than 30 minutes to try and solve this. Then they ran out of time to solve these easy problems here. Do you understand? So it means this question, even though it was a mistake and the lecture gave them full 7 marks, it affected their whole exam experience, because others didn't get this easy marks because they struggled here. So yeah, I'm just saying, if you see something like this, I've seen this thing twice already. If you see it X, A, B, C, D, just know that you're gonna check here how many variables are there in the expression. So you will just see it's A, B, C, D. Just scratch out the E. It might not be there. I haven't seen it again, but I saw it twice. So, okay. So now, in short, you need to basically just forget about this E, and then from there, you take this and you convert it into binary form, right? Then from binary, you take it to decimal, then you have your sigma notation. But we will do it. Let's do it quickly. Can't I like? I don't want this one. Okay. Okay, guys, I just want to write the question down. So this is X, A, B, C, D, X, A, B, C, D, which is equals to A, B, C, D, A, B, C, D, plus A, B, C, D. How many times? 2, 4, 6, 7 times. B, C, D, A, B, C, D, 2, 4, okay. C, D, A, B, C, D, 6 times. So the first one is not A, not A, and then this one not A, not D. Not A, not D. Yeah, and then this one, all of them are logic ones, and then this one not A, not C, not A, not C. This one not C, not C, not AB, not C. Then this one not AB and not BD. Not AB, not BD. Not AB. And then this one not BD, right? Am I correct? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So which one am I missing? Oh, sorry, number 3. So number 3, everything is high. And then the last one, not BD. Not BD. Not AB. Not AB. Not BC. Not BC. Not BC. Not AC. Not AC. Yeah, I think that will be the last one. Not AC. All right. Okay. So one easy method here is that we said, and guys, I prefer this method because no one will ever get this one wrong. Like the next step, basically, no matter who you are, even a grade 1 child will not get this one wrong. So why am I saying that? So here, wherever you see a not, you're going to put a 0. Wherever you don't see a not, it's a 1. So it basically means it's high, right? So for A, you're going to say A 0, 0, 1, 0, 1. Okay, I can't leave spaces. 0, 1, 1, 1, right? And then here, can someone tell me what will we have here?
0, 0, 1, 1, 0.
0, 1, 1, 0. Okay. Yeah, so now do you understand why I say no one will ever get this one wrong? 0, 1, 0, 1. 0, 1, 1, 0. 0, 0, 1, 1. 1, 0, 1, 0. All right. So remember when you convert into binary, let me write it just for people who were not here last week. So here we have basically 4 variables, right? So this one will be 2 to the power 0, the first one. Then 2 to the power 1. 2 to the power 2 to the power 2, and then 2 to the power 3. So 2 to the power 0. What is 2 to the power 0?
1.
It's 1.
1. It's actually 1. So everything to the power 0 is 1, guys. X to the power 0 is 1. Y to the power 0 is 1. So everything to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 2 is 4. This you don't need to calculate. It will always be like this, right? You must just know this significant bit, I think is the most, is 2 to the power 0, 2 to the power 2 to the power 2, 2 to the power 3. If it was 5 variables, this was going to be 2 to the power 4, which was 16. Everything moving to the left doubles itself. So this is 1, 2, 4, 8, 16, 32, 64, right? If you were going to the left, your lecturer, when he asked you guys to, I think the first 3 questions, he's gonna put, actually it's a she's gonna put 0.5 here for you guys, 0.5. So this 0.5 comes from, let me put a comma here. It comes from 2 to the power minus 1, 2 to the power minus 2, right? So after the comma, it becomes a negative. Minus 1, minus 2, minus 3, something like that. So 2 to the power minus 1 is a half, it's 0.5. 2 to the power minus 2, it's half of this. So it's going to be 0.25, for example. I'm going to erase this though. 0.25. 0.25, right? So meaning 2 to the power minus 3 will be half of this, 0.12 something, yeah, something like that, 0.12 something. So every time when you move into the left, you just doubling whatever you have. 1, double of 1 is 2, double of 2 is 4, double of 4 is 8. Do you understand? Now when you move in this side, you basically taking half of everything. 8, half of 8 is 4, 2, 1, 0.5, 0.25. Understandable? You will only get that when you convert in though. That's like the first 3 questions of the paper. All right. Okay, let's go to this problem. All right, so now we need to convert 111 into decimal, right? So 0111 into decimal. So this is what we do. So we check 1 basically means present and 0 means not present. So in this case, 1 here, we're gonna say 1 is present because of this one. 2 is present and 4 is present. So 2 plus, sorry, 1 plus 2 plus 4 is equals to 7. So the value for this one will just be 7, right? And then 0 is not present. But you guys can still do it like this. In your conversions now, let's say this is question 1, right? I'm just showing you question 1. For here, you can just write 7 here, right? But now let's say you were doing question 1, you had to convert this into decimal. So you need to show us, sometimes this is 19 marks, right? So you need to show us, you need to do something like, how do you do these things? Here, okay, let me do it like this. Okay, but you start from here. It's just that I'm typing, so I'm gonna start from the right. So you're gonna say 0, 0, which is this one. 8 was not present, right? So it's 0 multiplied by 8 plus, so this one 4 was present, right? 1 multiplied by 4 plus 2 and 1 and 2. 1 multiplied by 2 another 1, 1 multiplied by 1, 1 multiplied by. So this will give you a 0 plus 4 plus 2 plus 1, which is equivalent to a 7. So this is basically for question 1. Question 1, you can show these things. Like, let me make an example that you guys can see. So this is basically when they're saying convert this to decimal. You see 1, 0, 1, and show all steps. You see here it is show all steps. So you need to show those steps. You need to show this step that I showed you here, right? So you're gonna do it for this one, then you're gonna do it for this one, but they won't ask you such a long thing. Do you understand? They will just ask one thing. Maybe it will be maximum 8 digits long, or yeah, basically 8 digits long. That's the maximum. Normally it's 4 or 5 because they don't want you to get over 64. So yeah, highest, let's say 64, then your answer will be less than 124 or 128, something like that. Okay, so I was just showing you here. Let's go back to the main question. So 0, 1, 1, 1 will be a 7, right? So we're going to say it's equals to 7. Now I think we need to expose people now. Okay. So 0, 1, 1, 0. Let me see who we can ask for the answer. 0, 1, 1, 0. How do you check participants here? Bongu Tando. 0, 1, 1, 0.
Can I say the question again, please? 0. Oh, it's 6.
6. Excellent. 0, 1, 1, 0 is 6. Okay. Who is our thingy? 0, 1, 1, 0 is 6. Yeah. Next. Who's next? 1, 1, 1, 1. All right, yes, it's 15. Uh, 0, 1, 0, 1.
It's 5.
5.
Okay, yeah, that's true, it's 5. Okay, and then 0, 1, 1, 0, so it means this one. One of this is wrong. Okay, yeah, it's me who's wrong here. So this is basically 1, 0, 0, 1. So how much is 1, 0, 0, 1?
9.
Yes, excellent, it's 9.
Oh, yeah, it's 1.
Okay. Yeah, and then 0, 0, 1, 1, it will be a 3. So 10, 10 is a 10, guys. You don't even need to calculate it. 10, 10, always know it's a 10. So this is basically your answer in sigma notation. I think they use something like this and then they say M. So sigma notation is basically a sum of min terms. Yeah, so this is a sum sign, min terms M. Yeah, this is basically in sigma notation. So this is the easiest, and this is the method that your lecture uses as well. So yeah, if I were you guys, I will just take this one. Sometimes this is out of 19. You get 19 marks for this, but she doesn't care if you do it in 1, 2, 3 steps. You don't need to show all these things. These things I was just showing you so that you understand the others who haven't done this thing before, so that they understand easily where it's coming from. Okay. Any questions on that one?
No, it's clear so far.
All right. So guys, we're gonna run out of time. Please, let's go back to what we're supposed to fight with. So we're supposed to fight with Karnaugh maps. Karnaugh maps is basically a way to simplify a logic circuit, right? Yeah, here it is. So we use a kernel map to simplify logic circuit. So let me just explain. So normally when you're designing, let's say whatever you're designing, even if it's a radio or TV, anything, any circuit that you're designing, right? You'll be forced to like cut the costs. You understand? So now they will give you something like a truth table for that. Truth table, and say they want when this and this happens, the output must be like this, right? So now at first, when you draw the problem, you might have many gates, many gates. You might use a lot of gates in short, right? So kernel maps simplifies, it looks at the output and then simplifies that by reducing the number of gates. So kernel maps reduces the number of gates. Okay, so let me just give you tricks for this thing. So kernel map is a bit challenging. That's why in high school, students, they do it from grade 10. This one is grade 10. Logic gate is grade 8. All the gates is grade 8, but kernel maps, they only start you in grade 10. Together with the flip-flops and the SR latches. So that's grade 10. Okay, so the trick when you get to varsity is that they wanna change WX and YZ, right? WX, your lecture, right guys, your lecture likes to say WX must be your columns. And then your YZ must be your rows. So now, if I were you guys, not knowing, basically not being used to kernel maps and stuff, I would only practice this, because in all her papers, that's what she likes. She likes to say WX must be your column and YZ must be your rows. In high school, we were taught to draw it, what is it? WX was basically the rows and then YZ was the columns. That's how they taught us, and I believe some of you guys are still doing it like that. Simplify the following expression using a kernel map. Please make sure that you put WX in the columns. You see, here it is. And now if she wants it, like if she says this, it means you need to do it like this to get 100% basically. Okay, and YZ in the rows, right? So now let's draw the kernel map. So now to draw a kernel map, you need to first check how many inputs. You need to check how many inputs. So in this case, we have WX, Y, Z. Do you understand? So we're going to have like basically 4 inputs. Let's go to drawing. As long as we know the number of inputs, we will be fine. All right. Control Z. So WX is our columns. WX, Y, Z. Great stuff. So now the numbering of the kernel map is a bit different. So you're gonna have, because you have 4 variables, basically, you're going to have a total of 4 columns and 4 rows. So this is basically 4 columns and 4 rows. They only ask you guys a kernel map like this. They've never asked a 3 variable kernel map. But yeah, I do have it in my notes. You can practice, but they've never asked it so far. They've never asked that, and they're always referring to 4 variables. So the first cell will be 0, 0. right? So 0, 0 basically means W is 0, X is 0, right? This one will be 0, 1. Can someone tell me what will this one be?
1, 0.
1, 0. 1, 0. No. Yo, actually, I wanted you to see the trick, but now again, I went with your answer. Oh no. Okay, let me go. All right. Okay, guys. So this one is not 1, 0. This is the trick that I wanted to show you, right? This is 0, 1, but this is not 2. This is not 2. This is actually 1, 1.
So just
Am I correct, guys? No. Huh?
I'm asking, is that the only way to do it? Because I've seen where the 11 is where you put it, and then the 1 zeros on the other side. So is that the correct way, or it's one of the ways? So would I be
Okay.
wrong to say 1, 0?
Yeah, no, 1, 0, you will be wrong. She's gonna say the numbering is wrong, but we will look at my notes. I think I have another way to do it. I just wanna verify. Sorry, guys. I just wanna verify. Okay, this should be 1, 1. I'm gonna explain why is it 1, 1. But let me just verify with my notes quickly. So it's UNISA. UNISA notes, kernel maps. Which phase will kernel maps be? Okay. Sorry guys, this is one's complement. So kernel maps should be around 4. Kernel map series part 1. Same nodes groupings. Let's leave the groupings. Let's see. Phase 5.5. Kernel map series part 1. Maybe 6. Logic gates, expanded form. Okay, let's go to 4. Kernel map. Yeah, maybe series part 1 will have something that we need. All right, so we don't want that. Let's just look at the groupings, it's fine. Okay, all of them are 1, 1, say. So you need this thing called kernel map groupings. It's very important. This is where we're gonna get stuck, I can assure you. YZ, WX, YZ, kernel map, November 2016. WX as well. Yeah, this is another way that I was talking about. Okay, no. This third one must always be 1, 1, hey? This is another method that I wanted to tell you guys. Okay, so the logical explanation why this one is 1, 1 is that a kernel map is basically like a tennis ball. You understand? So these cells, they overlap. Besides that, I don't understand. I only know the logical explanation the professor gave me was that a kernel map is a tennis ball. So basically this cell here sees this cell this side. And then this cell here sees this cell here. And then this, this one here sees this one. So it's round, the kernel map is round. It's just that we are only taking one view of the kernel map. So the numbering will always be like this. Please be careful of the numbering. 0, 0, 0, 1, 1, 1, 1, 0. Understandable?
Yes.
Noted.
All right. Thank you. Okay. Then from, yes, is there any question? All right. Okay. Then from there, WX, YZ. So all of this, the first step is to convert them to, remember, if it's a bar, you need to take it to 0. If it's not a bar, you're gonna say it's a 1. So WX, YZ, this will just give us 0, 0, 0, 0. So we need to go plot this into the kernel map. 0, 0, 0, 0. So basically 4 zeros, right? So let's put it here. We'll say 0, 0, 0, 0. Great stuff. So now we look for W0, X0, Y0, Z0. So here it is. W, X, Y, Z. So now we then plot a 1 here. So we plot a 1 because this is in SOP form. Your lecture only asks you, actually in this module, you only do it in SOP form. You never do it in POS form. So you're lucky. So you will always have to plot a 1 wherever that output is true. Basically, wherever you see W off, X off, Y off, and Z off. So 0, 0, 0, 0, you're gonna plot a 1. All right, let's go to the next one. So this one, we can say is 0, 0, 0, 1. Agree? 0, 0, 0, 1. 0, 0, 0, 1. Let's see. 0, 0, 0, 1. Okay. So we look for W0, X0. So in short, this is 0, 0. You look for 0, 0 is the column. 0, 1 is the row. You put a 1 here. You don't need to complicate this thing. It's very, very simple. 0, 0, here it is 0, 0. The first one is the column. The second one is the row. 0, 1. Then you will just put the 1 here. Okay. You guys will plot the other one, the next one. Please focus a bit. So this one will be 0, 1, 0, 1, 0, 1, 0, 1. Actually, can't I do this? 0, 1, 0, 1. Okay, where do we plot this? Anyone?
I think on the second row and on the second column.
Yes, 0, 1, 0, 1. We plot it here. The next one. 1, 1, 0, 1. 1, 1, 0, 1. 1, 1, 0, 1. Can't I do this? Yeah. No, what is happening? 1, 1, 0, 1, I think, right? Yeah, 1, 1, 0, 1. 1, 1, 0, 1. So where do we plot that? 1, 1, 0, 1, where do we plot it?
Second row, third column.
Okay, 1, 1, second row. Okay, this is the row. Third column, okay, yeah. 1, 1, 0, 1. All right, I see you guys understand. So do you guys understand how to plot? All of you understand how to plot, right? Okay, 1, 1, 0, 1. So this one will be 1, 0, 0, 1, 1, 0, 0, 1. So 1, 0, 0, 1. So let's just plot it. 1, 0, 0, 1, 1, 0, 0, 1. Welcome. No, sorry, I start here. You see now I was making that mistake of starting with WZ. So what was it again? 1101.
01.
So basically 1101. No, it can't be 1101.
100.
1?
001.
One, yes. 1001. 100. Yeah. So it's gonna be, so it's gonna come here. 1001 will come here. Is there someone who can tell me what's the next one? Or do you prefer that I go check again? Let me check. Guys, I'm sorry, I'm lazy to use two monitors here, so we're gonna need to do this. 1001. This one will be 0011. 0011. Okay. 0011. Let me just write it down. 0011. So this will be 00 here and then 11 here. So we start with the columns. Columns we look for 00, then the rows 11. Okay, so the next one.
1111.
Thank you. 1111. It will come here. So all of, yeah, it's basically all ones, right? And then the next one.
0010.
0010. Okay, so we look for 00, then we look for 10. Here it is, 0010. And then the next one.
0101. It's
0101.
Sorry, it's 101.
1010. We look for 10 here, then we look for 10. So it's gonna come here. 10 column, 10 rows. And then the next one.
1110.
1110. 1110. Okay, so it's gonna be 11 here and then 10. So it's gonna come here. 11 column, 10 row. All right. Are we done, or is that the next one?
That was the last one.
All right. Okay. Now the boring part is done. Sorry. So now we need to group them together. So guys, when you group kernel maps, you can group them in groups of 1, in groups of 2, in groups of 4, in groups of 8, even in groups of 16. But for this module, you always end at 8. 8 is basically like your biggest group. So this means you will only have 4 different types of groupings, guys. So please don't like think this thing is difficult. Don't stress yourself. So remember what I said, these things overlap, right? So it means this one here can see this one here. So this one can always be grouped with this one because they are joined together. If you turn this toilet paper roll, right, this one here is going to end up being the partner of this one here. If you turn this as well as a toilet paper roll, this one is going to end up being a partner of this one. So these two basically. So you basically, everyone should be grouped. Sometimes you might find a case whereby you need to group a variable must be grouped on its own. I think I just wanna see if, yeah, here's the groupings. Let's just go through this ones quickly. You might find this, right? WX. You might find a 1 being alone here. So you might need to group this alone, guys. So this can be grouped alone, right? So if you were to group this alone, Your answer will be W, X naught, Y naught, Z naught. Do you understand? It's W, X not because of the 0, Y not because of the 0, and Z not because of the 0, right? If you group this thing alone. I'm gonna go to the next one. So remember, you group the ones together, but they must be next to each other. So this and this, you can also group, right? After grouping this and this together, okay, let's just focus on the groups. You can group, and then another one is when they next to each other like this, 4. So they can even be 4 here, they can even be 4 here, 4 here, but you always look for the biggest group. Even if they 4 here, even if they are here, it's fine. You can group them together like that. Sometimes they are straight like this. They can be straight downwards here. They can be straight like this, horizontally, vertically. It doesn't matter. You can just group them together like that. Now, this is basically the overlapping. Overlapping, remember I said this is basically a tennis ball or a toilet paper roll. So this one and this one, they are next to each other. You can just simply group them together. So here again, these two, you can group them together. It's a toilet paper roll, it's a tennis ball. So you can find this group of 4 by doing this, by overlapping them. Again, guys, at the corners now, you can also group them together like this. So now this is round. Remember, this is not a square. This is round. It's a tennis ball. You can group it like that. Okay, I showed you basically all the tricks there. Let's go here. So which group is the biggest group? It's very obvious.
I think it's the second row.
Yes. The second row is the biggest group. So it's basically 1, 1, 1, 1, 1, 1, 1, right? And now if you look, here is another group full of ones as well. So this group as well, full of ones, we can group it. So we can say this is basically our second group, it's fine. Then we have this 2, we can't group it with anything here on top. So these 2, we're gonna group them together, agree. So we'll just group them together here, right? And then this 2 here, this and this we can group together. It's either, yeah, here we have 2 ways. It's either we group this and this together like this, or we group this and this together like this. Do you understand? So we have 2 options. So let's take, which one is more challenging? They're both easy. But anyway, let's take this one. Let's group it together like this. So how many groups did we make? We had 1 group, the second group, the third group, and the fourth group. Yeah, okay, excellent work. So now let's simplify. Okay, so now I'm gonna ask, because I just want to understand how do you guys do it. I'm still doing it the high school way. So please tell me what is the expression, logical expression for this one. This group here, WX, YZ. What is the answer for this group? All right, not a problem. Okay, does anyone want to answer, or should I explain?
Please explain, Menier.
Yes. All right, excellent. Okay, I wanted to explain anyway. So guys, in Karno Maps, we look for things, I'm gonna say things, not to confuse you. Things that do not change states. So we look for things that remain the same. Listen to what I'm saying now. We look for things that remain the same. In that group, this means in that group, let's look at W in this group. W was 0, good. So meaning W must always be 0. W was 0, good. Then W became 1, then we lost interest, right? X was 0, X became 1, we lost interest because they change states. W changes states, X changes states. So now let's look at Y. Y is 0 in this group. Y is always 0 in this group because Y is like vertical. Do you understand? If the group was like this, Y was gonna be 0, Y was gonna be 1, it was gonna change state. Now Y is always 0. So we take Y as it is. Z is always 1 in this group. So we take Z as it is. So the answer for this one will be Y. Why not? Remember, it's 0, right? Y is 0. If it's 0, it's a not. Why not Z? Why not Z? All right. So this is this one. It's fine. I know it's still Chinese for now for some. Let's go to this group, then you'll understand. So now in this group, what is the value of W?
0.
In this group, 0. Does W change states?
So which one are we doing? The one going down?
Yes, the one going down.
No, it doesn't change.
It doesn't, because it only belongs to this first column. So in this first column, W will always be 0, X will always be 0. So our answer is gonna be, we're gonna start with W. W doesn't change state. So we're gonna say W. Because it's 0, we're gonna say W naught. X is 0. X doesn't, this group only belongs to this column, so X doesn't change state. It's always 0, it's only 0. So we're gonna say X naught because it's 0, right? Okay, now we here now. Okay, we here. Y is 0 in this group, in this long vertical group. Y is 0, Y is 0, Y is 1. So it changes states. We're not gonna take it because it changed states. So Z is 0, Z is 1. It changes states. So we're not gonna take it because it changed states. Do you understand? So we only take things that remain the same. We don't take things that change states. Okay. This example will explain properly. Let's go to this example. In this, let's start with the horizontal one. In this, what is this? In this row 10, this row 10. As you can see here, this group consists of this cell and this cell, right? This column and this column. So here, the value of W is 1, right? The value of W is 1, right? In this group, the first value is 1. What is the second value of W? Yes, it's 1. Yes, it doesn't change states. So we're gonna say W, right? Why? Because it's the same, it doesn't change states. Let's go to the value of X. X is 1, and then X is 0. So we throw it away because it changes state. It's not the same. So we throw it away. Then we come here. What is the value of Y? 1, yes. And now Y doesn't change states because it doesn't even include, what is it, this row just above it. It only belongs to this row. So 1, Y will always be 1 because it is only in this row, right? So Y doesn't change states. It will always remain a 1. So we're gonna put a Y, right? And then Z also belongs to this row only. It doesn't change state. So we're gonna put the Z naught because it's a 0, so it's gonna be a Z naught. All right, let's go to the last one, which is this one. So this one, what is the value of W? 1. Does W change states or not? W only belongs to this column. Yes, it doesn't change states. So we will have W, right? Because it only belongs to this column, right? Then X is a 1 as well. X doesn't change states because it only belongs to this column. This group belongs to this column only. So we will have WX. Great stuff. So now we're here between these two rows. This group has 2 rows. Now, if you look at Y is in this row, Y is 1, and here Y is 1. And it does, so meaning it does not change state. It's the same, right? Y is 1 and Y is 1. So we put a Y here. Why did we put a Y there? Because it's the same. Then Z is 1 and 0. So it changes states. So we don't put it, we discard it. So this is basically the answer to this Karnaugh map here. So in short, with Karnaugh maps, we look for things that do not change states. So meaning things that stay the same. You see this 1 and 1, this one here and this one here remain the same. So in this group, we will take Y. Do you understand? Because it remains the same. We will take Y if the group consisted of these two, basically these 2 rows. We will take the 1. Okay, let's say we were grouping this one and this one. W here is 1 and W here is 1. We will take W as it is. X is 1 and X is 0. We will drop the X. Why did we take the W? Because W remains the same. It does not change states. It's 1 and 1. Let's say we were here. We had 0, 0, 0, 0, 1. X 0, X 0. We will take X naught, right? And leave X alone. Sorry, we will take W naught, like W naught, this one. W naught 0, 0, because it does not change states. And then we will leave the X alone. Because X was 0, now X is 1. So it changes states. Understandable, guys? Any questions? All right. Okay, guys, I think we are basically done for today. Maybe let's just get input from you guys on what you want to focus on next. But Karnaugh maps, we're not done. We need to get different Karnaugh maps. So maybe next week we can just start with Karnaugh maps. Let's see, we have a Karnaugh map series here. There should be a series. There's part 1 and part 2. So I divided it into part 1 and part 2 because I know that your lecture, sometimes she can make it a lot of marks, like 11 marks. So part 2 is a bit different from this one, but yeah, and they basically ask the same questions. So, okay, so this is part 1. The first step I'm emphasizing here is 0, 0, 0, 0, 1, okay. This means W naught is equals to 0, X naught is equals to 0, Y naught. Okay, you guys understand this as well. I want you to start this step. Okay, please do this as step 1. Do the first step only, send it to me, okay. But this is, you guys are past that now. This is only when we start, like the first week. So you guys have even done assignment 2, so you should be able to do this. Please be sure to put WX in the columns. Okay, let's see this one. There's something that I'm looking for. Okay, the tough one that I'm looking for is not here, but yeah, please attempt to do this. You will get something like this in the exam, definitely. Now, if you can do, you don't even need to do the series part 2, right? If you can just do part 1, right? This part 1, then we mark it whenever we meet again. We mark it, you see, because remember, a Karno map is more or less more than 15 marks. Sometimes it's 19. Do you understand? So if we can do this, you already passed your exam. If you can just do the Karno map, the sigma notation. Remember, we still need to do the expanded form, but we're gonna take some time on the Karno maps because I don't want you guys to make mistakes with the Karno maps. Okay, anything from you guys that you want?
Sir, I was a bit late for the session, so where can I find solution for the homework? Because I missed the first question, I think. 1.4. I just want to confirm my answer.
So what was 1.4 again?
Prove A plus is equal to.
Oh, that drawing. Okay, so that will be in, this will be here. Okay, I will try and attach this to the, I don't know, I will upload it on my Unisa. Where is it? Okay, we drew it somewhere here, but I don't know which one is it now. Okay, I will. No, it was a truth table, right?
Yes.
It was a truth table. All right, what is your answer? I think our answer was 0 on the first one and everything else was a 1.
Okay. For both tables, right?
Yeah, the first one is 0, then everything else is a 1.
Okay. When they say prove, I can't remember if this was saying truth table, but is this the way that would always answer this question?
Yes. Yeah, it was saying proof using a truth table. So using a truth table, that's the only way to answer it.
Right.
You need to, yeah, but I will definitely upload it somewhere here. Just that I have such a lot of windows open. I don't even know which one is which. But yeah, I will upload it. But yeah, what we did is basically we took all the inputs, basically put them one side. All our inputs were here, which was A, B, C, something like that. Then we drew the truth table, right? And then from there we made our output. We started at some point we did A only, and then we did B plus C. You understand? B plus C here as our output. Then we got the output here only for B plus C, right? And then we did F. But you will see when I upload it. Then we said A or B, C. Then we got our output. So that this one was 0, then everything else was 1. Understandable?
Yes.
All right. Okay, next question. Okay, guys. So, it's fine. If you guys have any suggestions on what we can basically tackle. So next time we meet, we're going to tackle the Karno maps. Definitely, we need to tackle the Karno. I think that will be maybe, yeah, we're gonna tackle it twice, the Karno maps. Then from there is then that we can focus on your expanded form, Boolean algebra. What is it again? Yeah, then we're done with the syllabus. So if you have any questions, just post it on my Unisa, then I will see what to prepare basically for next week. Yeah, so we will decide if we want to meet next week because I see you guys understand this thing. So yeah, if you want to meet, please tell me on my Unisa. I know some of you are still shy, But yeah, just let me know.
Will do.
Okay, guys, anything? Oh, all right. Okay, I think that will be the end of our meeting. Yeah, we will continue. I will upload this on my UNISA, then we'll continue again next week. We will see who's interested. If not, we will meet that other week. Not a problem.
Thank you.
All right, guys. Okay, thank you for everything.
Thank you, sir.
Thank you, sir.
All right, cheers. Bye.
Bye.
Bye.